Okay, guys, so in this video, I am going to be discussing the converse of the Pythagorean theorem in the TEKS 8.7c. So let me project this really quick and let me hide this out of the way. All right, so on our formula sheet, we can find the Pythagorean theorem formula down here, and it will be right there. So what are we going to be talking about today? Well, we know that the Pythagorean theorem states that if a triangle is a right triangle, like we have here, this is a right triangle, and we know this because of this symbol here, that means that it is 90 degrees. If a triangle is a right triangle, then we can use the formula a squared plus b squared equals c squared. So we can use this if it starts off as a right triangle. Now, what does the converse say? The converse of the Pythagorean theorem, that states that if we can prove the a squared plus b squared equals c squared formula, then the triangle is a right triangle. So for example, if I am given numbers like 3, 4, 5, and they tell me to prove whether or not these numbers are a right triangle, then what I'm going to do is I'm going to take these numbers and I'm going to plug them into my formula. 4 squared equals 5 squared. Now, as you can see, the triangle that they gave me here, it does not have a 90-degree symbol. So I don't know yet if this triangle, let me put my numbers around it, if this triangle is actually a right triangle. I don't know that. So what I can do is I can just solve this. So 3 times 3, that equals 9. 4 times 4, that is 16. And then 5 times 5, that is 25. So 9 plus 16, that is 25. And I can see that these two numbers are equal to each other. So if these two numbers equal to each other, then yes, this triangle is a right triangle. So let's practice real quick. I have two problems here, but what I'm going to focus on is on the first one. And I went ahead and I inserted a triangle. This says the side lengths of a right triangle are given. Is each triangle a right triangle? So I have three numbers and I have a triangle here. Now I know that I need to label these numbers here. So I'm going to do A, B, C so that I can plug these numbers into the formula to see if it is a right triangle. That's what I'm trying to prove. So I'm going to use this as A. I'm going to use this as B. And I'm going to use this as C. Now, why do I do that? Because I like to use this formula in this manner. Just like whenever you go to McDonald's or any fast food place, they ask you, do you want a small, medium, or large? So I like this one as the small one. This is the medium, and this is the large. So that's how I'm going to look at these numbers. This is the small, this is the medium, and this is the large. So let me take these numbers and I'm going to plug them into my formula. So for my A, I'm going to plug in 5 squared. For my B, I'm going to plug in 8 squared. And for my C, I'm going to plug in 9 squared. So let me erase this here. Now, what I'm going to do is I'm going to take each one of these and I'm going to take them into my calculator to solve for each one of these here. So I'm going to go to my Desmos calculator. I'm going to type in 5 squared. Okay, that gives me 25. 8 squared gives me 64. And then 9 squared, that gives me 81. Okay, so now I'm going to come back over here. Oops. And now I am going to write these numbers out. So that number was 25. This was 64. and this was 81. So now it's just simple addition. I'm going to add these two numbers up, and that gives me a total of 89. And I brought this portion right here. I just brought that down here. Okay, so that's where I'm getting the 81 from. Now, what I can see here is that these two numbers are obviously not equal to each other. So what that means, put that there, that means that they're not equal to each other. That means that these three numbers here, they do not equal a right triangle. So the question was, is this triangle a right triangle? And we're going to answer no, it's not a right triangle. Now let's look at this one. It says the side lengths of a right triangle are given. Is each triangle a right triangle? So again, they're asking us, is this a right triangle? So these three numbers that we have here, 260 feet, 60 feet, and 80 feet. I went ahead and I inserted a triangle. And again, I am going to label out my A, B, and C. So remember we talked about small, medium, and large. We're going to label this as our A, this as our B, and this as our C. So let's write down our formula. A squared plus B squared equals C squared. And we're going to plug in our numbers. 60 squared plus 80 squared equals 260 squared. So for this one, I'm going to do this just a little bit different. I'm still going to use my decimals calculator. But now what I'm going to do is I'm going to type this in just this part. Not the equal sign, but just the 60 squared. So 60 squared plus 80 squared. And I can see that that gives me 10,000. Now I'm going to type in whatever's on the right side of the equal sign. So the 260 squared. Okay. So now let me come back over here. And let me go to my present from current slide. All right, so I can see that this portion here was equal to 10,000. And this other portion over here was equal to 67,600. We can obviously see that these two numbers are not equal to each other. So again, these three numbers are not in a right triangle. So is this a right triangle? No. Now, let's look at this one. It says a landscape designer is designing a garden in the shape of a right triangle. So we already know that he's going to shape his garden as a right triangle. Which of the following could not be the lengths of the sides of the triangle? Okay, so I'm going to do my small, medium, and large thing, my ABC, okay? So this is going to be my A, my B, and my C. And I'm just going to go ahead and I'm going to label that for all of these. This is A, this is B, and this is C. Okay, and I know that I'm going to be using the same formula for each. A squared plus B squared equals C squared. Let me write that over here. So what I'm going to do is I'm going to take each one of these numbers and I'm going to plug it into the formula that I have over here. So I'm just going to rewrite this as 16 squared plus 30 squared equals 34 squared. And I'm going to go ahead and I'm going to do that for each one of my answer choices just so that way I don't have to go back and forth from my calculator going back over here. Oops, I wrote the wrong number. And finally, that's going to be 18 squared plus 24 squared equals 30 squared. Okay, so now I've shown you how to use the Desmos calculator. So I'm going to show you how to use the N-Spire calculator, the ones that we have in the classroom. So I'm going to move this over here. And I'm going to go to a calculate screen. So using this, you could still do the same process like what we did with the Desmos. You can either break it down each one, do like 16 squared and then 30 squared equals 34 squared, add them up, and then you see if they're equal to each other, just like we did in the first example, like this. Or you could do it like this, where you put both of these equal to each other. Sorry, where you add both of these together in the calculator and then just get your total. Or you can use this step here. And this is the one that you guys are probably going to lean more towards when we're in the classroom. So we're going to type in exactly what we have here. Plus 30 squared equals 34 squared. So this will only work on this type of calculator. And then we press enter. And we can see that this tells us that it's true. So what does that mean? That means that these three numbers do equal a right triangle. So let me come back over here. Let me get my pen. So these do equal a right triangle. These three numbers here, they do equal a right triangle. But the problem is that we are looking for which one does not create a right triangle. Because it says which of the following could not be the lengths of the sides of the triangle. And we know that the designer already chose to use a right triangle. So we're looking for the one that is not true, or the one that is false. So I'm going to go back to my calculator over here. And I'm going to start to type this in. 10 squared plus 14 squared equals 17 squared. See, that one gives me false. I'm going to go ahead and I'm going to do the rest of these. Equals 14.5 squared. True. 18 squared plus 24 squared equals 30 squared. True. Okay. So coming back over here, let me present from this side. I know that this one is not a right triangle, this one is a right triangle, and this one is a right triangle as well. So again, they're looking for the one that is not. My answer here would be B.